Welcome back, class, to the lectures on media computation. Last time we discussed the sunset generation, and then we also saw this one, the grayscale conversion, color to grayscale image, and we then saw some things related to the creating different functions. So we normally create functions so that we can make them general and reusable. So functions we make them because we can use them many times, and normally function should be so much general that you can call it with different values. Okay, so we discussed this last time and we saw this example. These two codes over here, they do the same thing. So the code over here, mix and set, it has a one for loop, and inside the for loop we change the blue and then we change the green color. This is a different approach over here. Here what we do is that we have one function mix and set that will call two other functions, reduce blue and reduce green, and in each of these functions there are two for loops to reduce the blue color and then the green color. So one may say that this code over here on the right, it is more bigger, more large, number of instructions are more, and so it will be bad. But practically this approach is better because it is more readable for humans. So when the programs are big, the code that is well written, that is considered better, the one that humans can easily understand. And second important thing is that this code over here, it shows different uh, groups or functions separately. So there is a complete code over here to reduce the blue color, and here one complete function to reduce the green color. So it's more easy to understand this type of code as compared to this one over here. It's not easy. You don't know until you go into deep. It will not be easy for you to understand what is happening over here. So we have seen this already. And remember, the main theme of this whole discussion was that programs are written for people, not for computer. Computer can run any type of program which is correct, but it's for humans that they need to write such programs which are easy to understand. And so if you see this code, the variations, the two code types, we can only do this because we created two functions, reduce blue and reduce green. So all these two functions, they are doing a separate task, one unique task. Only one thing they are doing, one and only one thing. Okay. So when you have a big problem to solve, if you can divide it into small problems, then you can make them as separate functions. So let's say your big problem was how to make a sunset. You divide that big problem into small problems. One is to reduce blue color and the other was to reduce green color. Okay, and then you implement two functions for these two problems. So if we put the pick a file and make picture, then we would have to pick a file twice. Every time if I put a pick a file over here, make picture, and put a file make picture here, then every time I have to choose the file again, and this is not good. That's why we make the function such that the picture is coming from the outside as an input. So both these functions, they do the same thing, make the sunset, but practically the function over here is doing one thing only at the highest level. So when we discuss the highest level, at the highest level this problem is solved by making the sunset. So overall this whole program will create a sunset effect. At the abstract means at the high level, we are doing only one thing, but the hierarchical decomposition is a method where we divide this high level problem into smaller low level problems. So each smaller low level problems will do some small task. Okay, hierarchical decomposition means to divide the high level tasks into low level smaller tasks. So we have something that for example, if you have got something that you want your computer to do, what you do is redefine that thing in terms of smaller things. Okay, so bigger task was make sunset, smaller task is make reduce blue, reduce green, and you repeat this task until you know how to write that smaller thing. So now you know the smaller tasks are reduce, for example, blue. Another smaller task is reduce green. Now if you know these two smaller tasks how to implement, you will write the code for them separately. So instead of writing one big code for the overall program, always divide them into small tasks. This type of approach is also called as modular approach. Modular approach, where you create functions for each subpart of the problem. Clear? So we discussed that we will not put over here pick a file and make picture, we don't put inside the functions. These make picture and pick a file and make picture commands, they should be outside, and we will provide these functions with a picture object. So I provide from the outside this picture object, and then this picture object is then passed on to these two functions. So it will come over here, it will come over here. Clear? So make sunset, the picture is coming from the outside, so from where it will come, I have to create it. So in the command area, for example, or inside our main program, I will use these commands. I will use a pick a file, then I will use make picture. So first of all the file string is stored, then I will convert this file address into a picture object, and then I will call this make sunset function with this picture object. So picture object, I will pass it this one to this make sunset, so it will go over here, so it will come inside this place. And when the when the picture object comes here, it will then be passed to this function number 2 and this function number 3, and then I will go back. So remember that we have done this exercise in the class. We will go back at the end. When it finishes, we come back and we will show this picture. So picture gets modified in the whole process. So the execution occurs like this until this line, and from this line we run this code. Okay, so we execute these 3 instructions, 1, 2 and 3. This one does not finish, and in the middle we call this function, and all these instructions they run, and then we come back and we run this instruction. Clear? This is how it works. We have seen it so many times in the class. So when you want to use a function, so when you type, for example, in the command area make sunset picture, what happens is that whatever object that is in the command area variable picture, whatever object you provide over here, it becomes the value of the placeholder over there, okay, inside there. So for example, you call the function with the picture object, you created this variable. So this can be picture, or you can give it a name yourself, P1. Okay. So what happens when you call the function? This value will be passed to the next object over here. So let's say this is P2. Okay. Now these are different variables, but they will contain the same value. So P1, whatever value it has over here, this value will be passed to P2. Okay. Remember in the memory how these things work. If this is your computer memory, in the computer memory, for example, there is memory location. So this represents the data, your picture. Okay. There will be a variable that will point to this location, P1. That is a separate variable in another part of the memory, it will point to the start of the picture. When we pass this picture over here to P2, another variable is created in the memory P2, and it will also point to the same location. That is the reason when inside over here in this function, when you convert P2, when you make changes in P2, so P2 is making changes, but they are using the same object. So when you make changes to P2, it is basically also changing P1. So when you go back, it will change P1 too. So for example, this over here is the area of P1. Okay. So this one over here is P1. P1. Okay. Over here you have a different name. I put a different name. You can put same name, but they will still be different variables. P2. And similarly, you can have other variables also. Let's say you define over here another. So this one will be P2 because you define it. P2, P2. Here you define another variable. P3. Here in this function you define another variable. P4. So effectively, when you started, you create a picture object in P1. You pass this picture object to the function. The function stores it as P2. Function does not know P1. Okay. So what is happening is this thing, that in the memory you have a place, and in another part of the memory you have the variables P1. P1 will point to this location, start of the object. Then you create another variable P2. It will also point to the same location. Then you create another variable P3. It will also point to same location. And then P4. So when any one of them makes a change, for example, the code over here, P4, it makes change in the green color. It is making changes in the same picture. Then P3 will make changes in the, P3 will first make changes in blue color. Then P3 finishes. Then P4 make changes in the green color. All of them are making changes in the same picture. And then when you go back, when you finish a function, for example, this function is finished, P3 will finish. Then you start P4, this function, you make changes in the green color, and then when you finish this function, P4 will be gone. Clear? Finally, when you come back over here, after you have finished those two functions, and you finish this function, after finishing, when you go back over here, P2 is gone, finished. But remember, when P2 is gone, it does not mean that the picture is gone. Picture object is still over there. It is represented by P1. So at this point, P1 is still there, and it represents the same picture that was used by all three of them. Is it clear? Very important point. All these pictures, they represent the same picture object. These are only pointers to the picture, same picture. So like this, when you make changes, the only one picture gets changed, others are not. There is only one picture that's changed. They are not multiple pictures. So this was the concept. Make sure you understand it. If you don't understand, you can ask in the groups. So when you pass make sunset, you pass it picture, then it is passed as input to the reduce blue. So you pass a picture to make sunset, it will pass this picture to make blue, reduce blue and reduce green. And they will store their input variables as completely different from make sunset picture variables. So they can store it with a different name. For example, they store it with P3 and P4. So P3, P4, P2, they are different variables, but important point is they represent same picture object, same data. The variables are different, but the picture object is same. If P3 makes changes, it will affect the picture. P4 makes changes, it will affect the same picture. Nothing changes, nothing is different. I hope this is very, very important concept. This is a typical concept you should have brought from your programming courses, but it's never late. You can understand this now. So always remember that the names have context. Name is important. So in any language also, for example in English, you say I am going to fly to Vegas. So here the fly, it's a verb. But when you say, would you please swat that fly? Will you please kill that fly? So here the fly is noun. This is the fly that is an insect that flies in the air. So depending on the context, they are different variables. Similarly, when you provide a function, function will have its own context when you create a function. Whatever are the input variables, they are created and stored over there. For example, if you go back, if I have a function over here, reduce blue, inside this function p3 will exist, the variable p3. Inside this function, inside this for loop, I have a new variable called p. I have another variable in this for loop called value. So these values, these variables that are defined inside the function, we call them the local variables. So input variables that come, that we define, we call them placeholders. This is important thing for your exam also. Remember it. Placeholder is another name for input variables. So P2 is a placeholder, P3 is a placeholder, P4 is a placeholder. Placeholder means that it will take any value that comes outside, it can store that value. It's a place that can hold any value from the outside. So input variables, they are placeholders that take on the value of the input values, that they take on the value of the input variables coming from the outside only for the life of the function. Now this point is important, I explained earlier. When this function finishes, these variables, they finish. So P variable, it was defined, it will finish. Value variable, it is defined, it's finished. P3 will also finish, but P3 is basically representing another object already there. It is representing the same object which was pointed by P1. So when P3 is finished, it does not mean that that object is finished. Object will be still there, represented by P1. Okay? So this is important concept to remember. So the variables that are defined inside the function, they are over there for the life of the function. Till the function is there, these variables will exist. Function finishes, variables will also finish. So it happens only while it is executing. Variables that are defined within the function, they only exist within the context of that function, within the environment. So context is basically environment. So within the environment of that function, these variables, they will exist. Any variable, including the placeholders, input variable and local variables. So if you see, over here P3 is the input variable, placeholder, and these are local variables. They are called local variables, P and value. So P and value are local variables. They are also there. So overall, this environment of the function or context of the function, it is called as the scope of the function. Important exam question. It is called scope of the function. So P3, the scope of P3 is only this area. Within this area, these variables exist. P4 variable, the scope is this area. Within this scope, the variables exist. Outside this, the variables of P4 of this function, they don't exist outside this area. So this is scope. Scope means the environment of the variable, of the function. So remember this thing we have already repeated. Input variables, they are like placeholders. So it is something like it can store any object that comes from the outside. So think of the input variable as a placeholder. It takes the place of the input object. Whatever the object comes, it will be placed over there in that place. So during the time that the function is running or executing, the placeholder variable will stand for the input object. It will take the object like a picture and it will hold that object. So when you modify the placeholder by changing its pixels or value, for example with set red, you will actually change the input object. So when you make changes over here in P3, that change is actually made in the same picture object. That is the important point you understand. Clear? So if you modify the placeholder by changing something, by changing the value, that will actually change the object that was passed as input. Clear? So all those variables, this I have already discussed. The variable value, for example here, this variable inside the decrease red function, it is created in the scope of the decrease red. So this value is created inside this function. That means that it only exists while the decrease red is executing. When this function is running, only then this value variable exists. Outside this function, the value variable is not present. If you try to write over here value equal to 10, it will be error. Clear? It is error. So if you try to print the value after running the decrease red, it will work only if we already had a variable defined in the command area. Value, if you try to read it over here outside the function, it can only work if there is another value named variable outside that area. So the name value within the decrease red does not exist outside of that function. Very important. It does not exist outside this area. That's why we call them local variables. So we have seen very important concepts today. You should remember them for your exams also. Local variable, that is defined inside a function. Okay. Input variables are those variables that are passed as input coming from the outside. Okay. Your function receives those input from the outside. So these are called input variables. So input variable is another important term. Another name for input variable is placeholder. Okay. Then we also saw another term that was the scope of the variable. It means where these variables are. Scope of the function, sorry. Scope of the function means where the function variables or environment exists. Scope of the function is also called the context of the function. Clear? So this is what we discussed over here. So we saw over here today these some important terms. In the next class we will keep on moving and we will try to finish, and we will also discuss the project in the next class. See you all then.